If fructose is a survival signal, then here's the obvious question. Why did nature put it in fruit? Not hidden, not rare, but bright and sweet and fragrant and everywhere. That doesn't look like a mistake. It looks like a conversation. Fruit sits at the center of endless nutritional arguments. Is it healthy? Is it harmful? But those arguments usually fail for the same reason. They treat fruit as static. But fruit is not static. Fruit is dynamic, and it only makes sense when you follow the logic from both sides. Let's talk about the plant side. The plant's problem is that plants can't move. So if a plant wants its offspring to survive, it has to recruit an animal without losing the seed too early. That problem is solved chemically, not philosophically, not nutritionally, chemically. Now, unripe fruit is hard, it's sour, it's often bitter. This stage is dominated by fiber and polyphenols, compounds that protect the seed and discourage consumption. These same compounds also support fat burning, increase mitochondrial activity, push metabolism toward energy use. And from the plant's perspective, this is ideal because the seed is protected, the fruit is ignored, and time is bought. Not yet. As the seed matures, the plant's priorities begin to change. The fruit itself transforms, colors brighten, texture softens, aroma appears, fructose rises. Those defensive compounds fall. And the message flips. It says, now eat it. And the animals eat the fruit, carry the seed, and deposit it everywhere. The plant succeeds. Now comes the final stage, fermentation. Sugars are converted into alcohol, and it's not about flavoring, it's about timing. That seed's window is closing, and so the signal intensifies, telling the animal, eat it now. From the plant side, the sequence is elegant and efficient. It goes from defense to invitation to urgency. Now, what's the animal reading? The animal doesn't see the seeds. They read the chemistry. And fruit chemistry maps cleanly onto survival needs. Those bitter, polyphenol-rich stages of fruit promote fat burning and mitochondrial activity, and that helps when food is plentiful. But when food is scarce, increasing energy expenditure is dangerous. And so, animals naturally avoid this signal when survival is uncertain. Not because it's harmful, but because it's poorly timed. Ripe fruit sends a very different message. The fructose tells the body energy is available, so store some, slow expenditure, conserve your water. And it's exactly what the animal needs before migration, before drought, or even before winter. The animal benefits. And that fermentation with alcohol, again, adds urgency. Alcohol deepens the conservation response by increasing dehydration and stimulating internal fructose production. And so the message becomes unmistakable. Store aggressively. This isn't indulgence, it's preparation time. Here's where fruit becomes remarkable. Despite carrying a survival signal, whole fruit is usually safe because it's never delivering that signal alone. It comes with buffers. Water dilutes the sugar and hydrates. Fiber slows the absorption and limits the dose. Potassium offsets sodium-driven osmolality. Polyphenols reduce oxidative stress and support mitochondria. So even as fructose signals conservation, these buffers limit how strong and how fast that signal can be. Fruit itself is self-regulating. At this point, that healthy versus harmful debate collapses into one question. How strong is the fructose signal? And the research is remarkably consistent. The closer fruit is to being high in water, high in fiber, high in polyphenols, lower in fructose concentration, the more metabolically benign, even beneficial, it tends to be. And the further we move away from that state, more risk appears. The fructose signal becomes stronger when fruit fully ripens and polyphenols fall and fruit dries and water is removed, or fruit is juiced and fiber is stripped, or fruit is fermented into alcohol, or fruit is eaten in large quantities, or when fruit is available year-round. None of these are moral failures. They're simply signal amplifiers. The trigger stays and those buffers disappear. So here's the practical resolution. Fruit can absolutely be part of a healthy diet when it's eaten whole, when it's relatively high in water, and if it's not excessively sweet or concentrated. If it's consumed in moderate amounts, then it respects some sense of seasonality or rhythm. But fruit becomes metabolically risky when fiber and water are removed, when sweetness is concentrated, when quantity overwhelms buffering capacity, when exposure becomes constant background noise. Same fruit, different signal strength, different outcome. Fruit isn't simple because it contains both the trigger and the restraint, the signal and the safeguard. And that's why people can find studies supporting both sides. They're often studying different points along the same spectrum. So from the plant side, fruit is timing. From the animal side, fruit is instruction. And when those two perspectives remain aligned, fruit works beautifully. The paradox isn't fruit. The paradox is what happens when we amplify the signal and erase the limits. In the next episode, we'll step out of biology and right into history. For most of human history, fructose was rare and seasonal and tightly tied to survival. And then in a very remarkably short period of time, trade, industry, and technology made it a constant. We're going to trace that shift and how it happened and what followed. Because as fructose exposure rose, so did obesity, diabetes, fatty liver, hypertension, gout. Correlation is not causation, but when history, biochemistry, and disease trends all move together, that pattern becomes very hard to ignore.